Wi-Fi. It's like this invisible force that pretty much runs our daily lives, right? From our morning coffee and emails to our evening movie streams, it just works. It feels like magic. But it's not. It's an incredible piece of technology, and in this explainer, we're going to pull back the curtain and turn that magic into method.
It's a fantastic question when you actually stop and think about it. We are so dependent on this thing, but how many of us can really say we know how it works? Well, we're about to fix that. Okay, so here's our game plan. First, we'll talk about the invisible connection itself. Then, we'll get into the highways our data travels on. After that, we'll see how to dodge digital traffic jams, how to properly lock your network's front door, and finally, how this all scales up to build the wireless world we live in.
All right, let's dive right into Section 1, the invisible connection. You know, when you strip away all the complex stuff, Wi-Fi is basically just a super sophisticated two-way radio. Seriously. Forget magic for a second and think walkie-talkies.
So, a wireless local area network, or WLAN, which is the technical term for a Wi-Fi network, uses radio waves to send and receive data. And that's where this term half-duplex comes in, and it's super important. It just means that on any single channel, a device can either talk or listen, but it can't do both at the exact same time. It's just like a walkie-talkie. You have to wait for the other person to finish before you can hit your button to talk. Over.
Okay, so we've established Wi-Fi is radio. But here's the thing, not all radio waves are created equal. You can think of the available frequencies as public highways for our data, and just like real highways, each one has different speed limits and rules of the road.
The two main highways you've probably heard of are the 2.4 GHz and 5 GHz bands. The 2.4 GHz band, that's kind of like your local scenic route. It goes a long way, it's great at getting through obstacles like walls, but it gets crowded really easily. The 5 GHz band, on the other hand, is your superhighway. It's way faster with a lot more lanes, so it's less congested. The catch? The signal doesn't travel nearly as far and gets stopped pretty easily by solid objects.
And this is where all that alphabet soup you see on the side of your router box, 802.11b, G, N, finally starts to make sense. These are just the names for the different rules of the road. The early ones, like B and G, could only use that crowded 2.4 GHz local road. Then, 802.11n was a huge leap because it could use either highway. And of course, today we have even newer standards like Wi-Fi 6 that are all about making these highways wider and more efficient.
So we have our highways, but what happens when there's a traffic jam? Because just like real roads, these airwaves can get seriously congested. Let's talk about how to navigate that.
Oh, we've all been there, right? You're staring at full bars of Wi-Fi, but trying to load a simple website feels like you're back on dial-up. What is going on? Well, the culprit is almost always interference. See, that 2.4 GHz highway is, well, it's a party, and everyone's invited. It's not just your Wi-Fi. Your microwave oven, when it's running, is shouting in that same space. So are older cordless phones and a lot of Bluetooth devices. But honestly, the biggest cause of traffic is usually just all of your neighbors' Wi-Fi networks trying to use the same bit of road at the same time.
So what do you do about it? Well, each highway is split into multiple lanes called channels. And there are tools, even simple apps for your phone, called Wi-Fi analyzers that let you see this traffic. You can see which lanes are jam-packed. A lot of routers just default to the same 1 or 2 channels. So a really simple fix is to just log into your router settings and manually switch to an emptier lane. It can make a world of difference.
Okay, having a fast connection is awesome. But what good is it if your digital front door is wide open? Security is absolutely crucial. And just like the technology for speed has evolved, so have the locks for our digital doors.
Think way back to 1999. We got WEP. It was our first attempt at a lock, and, well, it was a pretty flimsy one. Thankfully, it was soon replaced by WPA, which was a massive step up, and then WPA2, which has been the gold standard for security for years. Now we're even seeing its successor, WPA3, rolling out.
So, what was so bad about WEP? Well, its biggest flaw was that it used a single static key. That means the password you typed in was the only key used to lock and unlock all the data for everyone on the network, and it never ever changed.
And having a key that never changes is a gigantic security hole. It's the digital version of hiding your house key under the doormat. As soon as one person finds it, the lock is useless forever. That's why today, if you see WEP as an option, you should run, not walk, in the other direction. It is completely insecure.
This is where WPA and especially WPA2 totally changed the game. They introduced what we call dynamic keys. And this quote from one of our sources really hits the nail on the head. The keys can change while the system is being used. So instead of one key under the mat, WPA2 creates a unique, temporary key for every single device every time it connects. It's like a lock that changes its combination every few seconds.
Okay, let's zoom out a bit. We've talked about the waves, the highways, and the locks. But what's the actual hardware that makes all this happen, especially when you move beyond a simple home network and into a big office or a college campus?
At the heart of it all is the wireless access point, or just AP. It's the thing that's actually broadcasting that Wi-Fi network name, the SSID, that you see on your phone or laptop. Now, in your house, your router and your AP are usually the same box. But in a big building, you'll see these dedicated APs mounted on ceilings everywhere. They are the crucial bridge between our wireless gadgets and the physical wired internet.
But think about it. In a huge organization, like a university with thousands of students, you can't just have one password for everybody, right? That would be a security nightmare. Every time a student graduated, you'd have to change the password for everyone else. It just doesn't scale. What you really need is a bouncer at the door, checking everyone's individual ID.
Well, that bouncer has a name. It's called Radius. Here's how it works. When you try to connect, the access point doesn't know the password. It just acts as a gatekeeper. It says, okay, give me your username and password. Then it takes your credentials and passes them back to a central, highly secure Radius server. That server has the master list. It checks your ID, and if you're on the list, it sends a message back to the AP saying, yep, they're good. Let them in. This is so much more secure and manageable.
Okay, we have covered a ton of ground, so let's boil it all down. What are the key things you need to remember for your own Wi-Fi? 1. At its heart, it's just fancy radio. 2. Pick the right highway. Use the 5 GHz band for your important high-speed stuff if you're close enough. Use 2.4 GHz for things that are farther away. 3. If your internet feels sluggish, check for traffic jams. A Wi-Fi analyzer app can help you find a clearer channel. And 4, most importantly, lock your digital door. Please make sure your home network is using WPA2 security at a minimum, or even WPA3 if your gear is new enough.
So, there you have it. From invisible radio waves and data highways to digital deadbolts and network bouncers, you now know the method behind the magic. So the only question left is, what are you going to do with this new knowledge? Will you go hunt for a better channel? Double-check your security settings? Now the method is in your hands.